Hello, I'm Mr. Blazic,
And I'm Mr. Hildebrandt.
and we are taking the last few days of our vacation to bring this video to you.
And it is really nice, but it's time for school to start. This video is brought to you from BS Chemistry.
My first name is Brian.
My first name is Sean, hence BS Chemistry. Today we're going to present Whiteboarding 101. All right, Brian, this is take 27.
Okay, we got to remember to cut it out.
Yeah, we will. We'll cut it out.
Okay. We are working together to provide great chemistry curriculum. We will be using the balloon activity that we did earlier to model what we are looking for during a whiteboarding session. Every lab that we do, we will be asking you to use this method in your lab groups. For the balloon lab, we had one balloon filled with air.
And one with helium. Every time you get into your groups, we're going to expect you to divide your whiteboard into quadrants. We're going to explain to you what we'd like to see in each quadrant.
The idea of the verbal quadrant is to contain words that you would actually explain to somebody what your main idea or thought was. In the case of the balloon lab, we wrote the mass of the particles in the helium balloon is less than the mass of the particles in the balloon filled with air.
And I think what you would understand is that a helium balloon floats, so it probably is a little bit lighter. That's why it does float. So going to the mathematical quadrant, you basically want an equation here. And this isn't a great example, but what we came up with for this example is the mass of basically the air balloon mass minus the mass of the helium balloon to get that difference, so you could determine which one was lighter and which one was heavier.
And you know several symbols such as greater than, equal to, and that sort of thing that would work. In the diagram quadrant, we expect you to produce some picture that more than likely will include particles. We talk about particles all year in chemistry, so we would expect to see particles. In this particular example, you'll see that we have two different kinds of particles, and I have my key. So the blue particles, or little circles, represent air. The little green circles represent helium, and we felt that there were fewer particles of the helium in the balloon, which perhaps made it float or elevate higher than the air balloon, which has more particles of air.
All right, and finally, the graphical, and it is what it sounds like. You're creating a graph. And this one was a little bit tough too, but think about a balloon and what happens to a balloon over time. It kind of shrivels up. So what we did here, we had our X and Y axes, and we did the mass on the side of the balloon. You could have used both balloons or just one. And then over time, we use days because usually a balloon isn't going to change that much in hours. So we decided to use days. And you can see in our example, the mass is going to drop over time.
From Jamaica, man. That's all, folks. Peace out.